Hi friends, welcome to JS Maths Academy. Today we are going to discuss about the basic proportionality theorem. It is also known as the Thales theorem. Let us observe the statement of basic proportionality theorem. If a line drawn parallel to the one side of a triangle to intersect the other two sides in distinct points, then other two sides are divided in the same ratio. Let me read the statement again. If a line is drawn parallel to one side of a triangle to intersect the other two sides, that means if we draw a line as parallel to one side of a triangle, see here I have drawn a line D which is parallel to the one side of triangle ABC, that is BC. Then other two sides in distinct points, it is intersected other 2 points at distinct points, that are D and E. Then other two sides are divided in the same ratio. See, this DE divides AB and AC in different ratios. Let me take a DE. DE divides the side AB in the ratio of in the ratio of AD by DB. Then DE divides the side AC in the ratio of AE by AC. So what is this statement is saying that this DE divides these two sides in the same ratio. That means we need to show that AD by DB is equal to AE by AC. We need to show that AD by DB is equal to AE by AC. For this, firstly, to prove this theorem, firstly we have to write that what is given to us. We have given that in a triangle ABC, DE is parallel to the BC, in which intersect the sides AB and AC at D and E respectively. That means DE divides the side AB at a point B and AC at E. And what they are asking us to show, that we have to write in a required to prove. So it is required to prove that AD by DB is equal to AE by EC. For this, we need to do the small construction. That is, we have to join B and E. We have to join B and E. So let me join that. I am joining B and CD. I have joined CD. And then draw DM perpendicular to AC. That means we have to draw a perpendicular line through the point D to the AC. We have to draw a perpendicular line to the AC through the point D. So let me draw a perpendicular line here. This is a DM. Then EN is perpendicular to the AB. That means through the point E, we have to draw a perpendicular line to the side AB. Through the E, we have to draw a perpendicular line. Let us take, this is a perpendicular line. This is a EN. This is what? EN. This is N. So here, before going to learn about the proof of this, student has to understand the two important concepts. Let me explain that concept. First one is regarding to the area of triangle. Area of triangle. If you take area of triangle, if you take a right angle triangle, then if they ask us to find out the area of this one, we write that half into base into height. Area is equal to, we write it as half into base into height. Then what would happen if it is a obtuse angle triangle? In the obtuse angle triangle, then if you consider one of the side as a base, then what would be the height? In a right angle triangle, we can consider one side as a base and other side is a height. That is legs of right angles. In that one leg we consider the base, another one becomes height. But in case of obtuse angle triangle, then if you consider height is one side is a height, if you consider one of the side is a height, then can we consider any other side in this as a height of this? Means no. In such cases, if you consider AB as a height, if you consider AB as height, but so AB as a base, then for this base from the opposite vertex we have to drop a perpendicular line. So in such cases, here if you drop a perpendicular line CD, Then in this case we get area is equal to half into base AB into height CD. In this case, you children has to understand that in obtuse angle triangle, height won't be an interior part of a triangle. It can be exterior part of a triangle. This is the first case. Next, second case is what? About areas of two triangles. Area of two triangles which are having same base. And between same parallels. So let me take an example. I have taken a parallelogram. Let us assume that it is an ABC is a parallelogram in which AD, so BD is one diagonal and AC is another diagonal. So here we got two triangles, one that are triangle ABC and triangle ADB. So these are the two triangles, and these two triangles are having same base, that is BC. They are having same base BC, and between the same parallels that are AB and CD. So whenever two triangles are having same base and between same parallels, their areas are equal. That means area of triangle ABC is equal to area of triangle ADB. So if the students understand these two concepts, then they won't confuse to prove this theorem. So I think you got a clear idea regarding to the two concepts. One is area of triangle. While finding out area of triangle, height of the triangle is not necessary to be interior part of that particular triangle. This is first point. And second point is that if two triangles are having same base and between same parallels, then that two triangles are equal in area. These two concepts children has to understand. Then let me prove the theorem. Let us go to the theorem. See, this theorem, proof of this theorem totally based on the triangle. That means diagram itself. So while doing the proof, you must understand the triangle or which triangle we are considering. Then in which triangle what side we consider as the base. So let me take a first triangle, that is a triangle ADE. So I am going to take area of triangle ADE. So is it right? Excuse me, is it a right angle triangle? Means no, it is not a right angle triangle. Then in such cases, to find out area of a triangle, we can consider any side as a base, and if you consider AD as a base, then a perpendicular line which is drawn through an opposite vertex, that will equal to height. So I am considering this AD as a base, and it's a perpendicular line which we have drawn through an opposite vertex, that is E, that is EN, that is a height. In the same manner, I am going to take the area of a triangle BDE. Area of triangle BDE. Area of triangle BDE. This triangle I am considering. This triangle. Area of triangle BDE. So in this case, here, what is the base? Base here, so I am considering base as an AB. I am considering BD as a base, and if BD is a base, then what would be the height? A perpendicular line which is drawn to the opposite vertex. So through point E, what was the perpendicular line which is drawn to this BD? Means that is EN. Here also we consider EN as a height for this triangle BDE. That means which is an exterior to the triangle BDE. Now I am going to take a ratio between these two. That means area of triangle ADE and area of triangle BDE. The ratio between this, if you take, then you get as an half into AD into EN is an area of triangle ADE. Then area of triangle BDE can be written as half into BD into EN. Now we can simplify it. We can cancel as en and half of it can get cancelled, and this can be written as AD by BD. AD by BD. Now this can be written as area of triangle ADE by area of triangle BDE, can be written as AD by BD. This is the first equation. This is the first equation. Now let me take another triangle, that is triangle CDE. If you consider in triangle CDE, if you take triangle CDE, in this triangle CDE, if you consider AC as a base, then perpendicular line which is drawn through the point D, that is DM. DM will be the height for this triangle CDE. So I am going to write the area of triangle CDE. Area of triangle CDE, that is half into base. What side we consider as the base in this triangle? That is EC or CE. Also I am taking EC. Then height for this EC, height is nothing but DN. Here also it is an axial to the triangle CDE. Height is DN. Now let me take a triangle ADE again. Area of triangle ADE. Can we write area of triangle in another manner? Means let us observe the diagram. Area of triangle ADE. While finding out area of triangle, in the first case we have taken AD as a side, AD as a base, then perpendicular line which is drawn through the opposite vertex, EN becomes height. Then in the same manner, can we consider AE as a base for triangle ADE? Means yes, we can consider AE as a base. In this case, if you consider AE as a base, what would be the perpendicular line which is drawn through the opposite vertex? That is D. Then DM. DM becomes a height for the triangle ADE. DM becomes a height for the triangle ADE. That means area of triangle considering as an half into base. Here I am considering base as an AE, and height becomes a DM again. Now I am going to find the ratio between these two areas, these two triangles, That means area of triangle ADE by area of triangle CDE. So I am going to write area of triangle ADE. In this case, we consider half into AE into DM by half into EC into DM. Now DM is cancelled, half of it cancelled, you get it as an AE by AC. AE by AC. That means what we got, area of triangle ADE and area of triangle CDE is equal to AE by EC. Now what we require to prove? It is required to prove that AD by DB is equal to AE by AC. AE by AC. That means in there, if you consider this is the second equation, in the second equation RHS part, and in the first equation RHS part. What is the first equation? What we got here in the first equation RHS part? We need to show first equation RHS and second equation RHS parts are equal. To that we need to show, if you are able to show area, that means LHS part of these two equations are equal. If LHS parts of two equations are equal, then we can say RHS also equal. For this, we have to compare LHS parts of the both equations. What are the LHS parts of both equations? Equation 1 and equation 2. In the equation 1, LHS part what we have, that is area of triangle ADE by area of triangle. What triangle we consider in the first equation? That is BDE. In the second equation, what we have a LHS part, that is area of triangle ADE and area of triangle CDE. If you observe this, if you observe the both LHS parts of equation 1 and equation 2, if you observe both LHS parts of equation 1 and equation 2, in this numerator part, area of triangle and area of triangle are equal. That means numerators are equal. Then to show these LHS parts are equal, it is enough to show only denominator parts are equal. That what are the denominator parts? That is area of triangle BDE and area of triangle CDE. Now, can we show these two triangles are equal in area? Means let us observe the triangle. In triangle, we need to show triangle BDE. Triangle BDE. Let me write in here. Triangle BDE and triangle CDE. Both areas are equal. That we have to show. How we are going to prove? That means if you observe these two triangles, in these two triangles, base DE is a common base. These two triangles are having same base, that is a DE, and between the same parallels, that are DE and BC. That means triangle BDE and triangle CDE are having same base EC and between the same parallels DE and BC. So their areas are equal. So that we have to write here. Here triangle BDE and triangle CDE are having same base. What is common base that they have? That is DE, and between the same parallel lines What are the parallel lines that we have? That are DE is parallel to the BC. DE is parallel to the BC. So both areas are equal. That means area of triangle BDE is equal to area of triangle CDE. That means if you observe this, LHS part of first one and LHS part of second one, both are equal. Why? Because numerator parts ADE is equal. Then denominator parts area of triangle BDE is equal to area of triangle CDE. Both are equal. That means in both equation 1 and equation 2, we have LHS parts are equal. As LHS parts are equal, then we can equate the RHS also. So from the equation 1, 2 and 3, from these three equations, we can write that AD by DB is equal to AE by EC. That means RHS parts of both equation 1 and equation 2 are equal. This is only required to prove. So hence we proved that if a line drawn through the parallel to the one side of a triangle, as it intersects the other two sides at two distinct points, then that divides the other two sides in the same ratio. That means AD by DB is equal to AE by EC. Thank you friends for watching this video.